In question number 2, you have got triangle PQR, right angled at P, and P and M is a point on QR such that PM is perpendicular to QR, and we have got to prove that PM square is equal to QM into MR. Let us consider triangle RPQ and triangle PMO. You will have angle RPQ, this is the right angle, and PMQ, the another right angle, they both are given. Now you have got triangle RPQ. You have got angle 1 plus angle RPQ, and angle 2 is equal to 180 degrees by angle sum property. And similarly, if you consider triangle PMQ, you have got angle 4 plus angle PMQ plus angle 2 is equal to 180 degrees, right? Equate the two equations and you'll get that angle 1 is equal to angle 4, and similarly, we can also prove that angle 2 is equal to angle 3, right? Okay, now you consider triangle QMP and triangle PMR. You know that angle 1 is equal to angle 4, angle 2 is equal to angle 3, and angle PMR is equal to angle QMP, each equal to 90 degrees. So, triangle QMP will be similar to triangle PMR by AAA similarity theorem, right? Now, let us now consider the triangle QMP and triangle PMR. They both are similar as we know. So the area of triangle QMP by area of triangle PMR is proportional to the square of the respective sides, which is corresponding to each other, that is opposite to the same angle. Now I know that angle 2 is equal to angle 3. So the side which is opposite to angle 2 and the side opposite to angle 3, we have got PM and RM respectively. So we can write here as PM square by RM square, right? Okay. Now, what is the area of triangle? We also know that it is equal to half base into height. So for area of triangle, we can write half of QM into PM. And for area of triangle PMR, we can write half of RM into PM, right? Now, in this, we can cancel this half and half, this PM and PM, one of the RM and this RM ka square. So, what is left? QM is left here, PM square is left here, and instead of RM square, only RM is left. Cross multiply, you will get the required answer as PM square is equal to QM into MR, and this is what we are supposed to prove. In question number 3, the figure triangle ABD is a triangle right angle at A and AC is perpendicular to BD. Show that AB square is equal to BC into BD and AC square is equal to BC into DC and AD square is equal to BD into CD. Now, what you can see here is, in the given diagram, triangle ACB, triangle DAB and triangle DCA are similar to each other because each of them has got one of the right angle and the other one is the green angle which is equal, right? Being common, so we can have triangle ACB and triangle DAB similar to each other, and we know in similar triangles the area of triangle ACB by area of triangle DAB is equal to AB square by DB square, that is both the sides are the sides opposite to the right angle, that is the hypotenuse, right? Okay, now we can also write the area of triangle as half base into altitude. So for triangle ACB we can write half BC into AC, and for triangle DAB we can write half DB into AC, right? Okay, now what you can do is you can cancel out the common things. So AC and AC cancels. Here DB and DB square will get cancelled. So what is left here is AB square is equal to BC into BD. Similarly, you can also do it for other relations. In question number 4, we are given that triangle ABC is isosceles triangle right angled at C. We are supposed to prove that AB square is equal to 2 times of AC square. We are given triangle ABC is isosceles. Right angled at C. So we will have AC is equal to BC, right? So in order to prove whatever it is given, that is AB square is equal to 2 times of AC square, we have to consider the Pythagoras theorem for triangle ABC. We know that this side AB is a hypotenuse, so AB square is equal to AC square plus BC square. But we are given that AC and BC are equal, right? So instead of BC, we can also write as AC. So AB square now becomes AC square plus AC square. Hence, we have got AB square is equal to 2 times of AC square, and that is what we are supposed to prove. In question number 5, triangle ABC is isosceles with AC is equal to BC, and if you have got AB square is equal to 2 times of AC square, prove that triangle ABC is right angled at C. So for that, let us consider the triangle ABC, in which you are given that AC is equal to BC and also that AB square is equal to 2 times of AC square. Now we can write this 2 times of AC square as AC square plus BC square, right? Okay, so you have got AC square plus BC square is equal to AB square. Therefore, by converse of Pythagoras theorem, triangle ABC is a right angled triangle, and that is what we are supposed to prove. Question number 6. In triangle ABC, which is an equilateral triangle of side 2A, is given to you, and you have to find out each of the altitude. That means if I draw a triangle ABC which is equilateral and each of the side is of length 2A, we are supposed to find out the altitude of the triangle, and here the altitude is AD, right? In order to find it, in triangle ABC, we know that AB is equal to BC is equal to CA, and that is equal to 2A. Now what is BD now? A perpendicular is drawn from one of the vertex to the opposite side, and we know in an equilateral triangle, the perpendicular from the opposite vertex bisects the side. So, this BD will be equal to DC and each of them will be equal to BC by 2. But we know that BC is equal to 2A. So, 2A by 2 is equal to A, right? Also, we know that angle D is equal to 90 degrees. So, if you want to apply the Pythagoras theorem in triangle A, B and D, here it should be D. We know that AB square is equal to BD square plus AD square, or we can write AD square is equal to AB square minus BD square. So, instead of BD square, we can write it as AB square by 2, because BD is equal to BC by 2 and BC is equal to AB, that is equal to AB by 2. So, we have got AB square minus AB square by 4. On calculating the values, we get that is 4AB square minus AB square divided by 4. So, 3AB square by 4 is equal to 3 times of 2A square by 4, because we know 2A, AB is equal to 2A. So, substitute the value and calculate the value of AD. We get it as root 3 times of A, and this is the answer. In question number 7, you have got to prove that sum of the squares of the sides of the rhombus is equal to sum of the squares of its diagonal. For this, you are given a rhombus ABCD, wherein you know that AB is equal to BC is equal to CD is equal to DA, right? Okay. Now, for this, you have to consider the known facts about the diagonals of a rhombus. What you know, that they bisect each other at 90 degrees, right? Okay. So, we will have in the triangle AO and B, that angle AOB is equal to 90 degrees, and also we will have OA is equal to half of AC, right? Okay, and similarly, we will also have this OB is equal to half of BD, right? Now, using Pythagoras theorem, we know that AB square is equal to OA square plus OB square. But instead of OA square, you can write half of AC square. Instead of OB square, you can write half of BD square, right? So, slightly calculate and you will get AC square plus BD square is equal to 4 times of AB square. Now, 4 times of AB square can be written as AB square plus AB square plus AB square plus AB square. Now,
you can also write, instead of AB square, BC square, CD square and DA square, put the values, and you now have proved whatever you want. You wanted AB square plus BC square plus CD square plus DA square is equal to AC square plus BD square. We have proved it here.
Let us do question number 8 now. O is a point in the interior of the triangle ABC and OD is perpendicular to BC, OE is perpendicular to AC and OF is perpendicular to AB. You are supposed to show that OA square plus OB square plus OC square minus OD square minus OE square minus OF square is equal to AF square plus BD square plus CE square. Also, you are supposed to prove that AF square plus BD square plus CE square is equal to AE square plus CD square plus BF square. Do a small construction here. In this, you can see that we are joining O to A, B and C to get OA, OB and OC, right? Now you can see a lot of right angle triangle in the diagram, and so you are going to apply Pythagoras theorem. Now first you consider triangle OFA. Here OA is the hypotenuse and OF and AF are the perpendicular sides. So what do you get? OA square is equal to OF square plus AF square, but we want here as OA square minus OF square. So take OF square this side and you can write this equation as OA square minus OF square is equal to AF square. Similarly, you can write for triangle ODB and also for triangle OE and C. Right? Now, you mark them as equation 1, 2 and 3. Now, add them. On adding equation 1, 2 and 3, you will be getting OA square plus OB square plus OC square minus OD square minus OE square minus OF square is equal to AF square plus BD square plus CE square, right? Okay. Now, similarly, you can also obtain the relationship OA square plus OB square plus OC square minus OD square minus OE square minus OF square is equal to AE square plus CD square plus BF square, and mark this as equation number 5. Now, equation number 4 and 5 are the same thing. So, from equation 4 and 5, we can prove that AF square plus BD square plus CE square is equal to AE square plus CD square plus BF square, and this is what we are supposed to prove.
In question number 9, a ladder 10 meters long reaches a window 8 meters above the ground. Find the distance of the foot of the ladder from the base of the wall. Here comes the ladder, which is BC. Window is B, and you have got the distance from the ground to the window is AB, 8 meters. You are supposed to find out AC, which is the distance between the window's base, that is the wall, and the base of the ladder. Let it be equal to X. Now you can see that it is a right angle triangle, so you can apply Pythagoras theorem. So you have got AB square plus AC square is equal to BC square. 8 square plus X square is equal to 10 square, which you can solve and get X is the root of 36. So X is equal to 6 meter, right? And that is your answer. In question number 10, it is given that an aeroplane leaves an airport and flies due north at the speed of 1000 kilometers per hour. At the same time, another aeroplane leaves the airport and it is speeding towards west with a speed of 1200 kilometers per hour. How far apart will the two planes be after 1.5 hours? You can see that the plane 1, which is going towards north, and another one is going towards south. After 1.5 hours, if you can calculate the distance OA and OB, the distance between them will be equal to AB, right? So for that, let us apply the basic formula. You are given the speed of the plane and you know the time. So, can you calculate the distance travelled by the plane 1 in 1.5 hours? Yes, you know that distance travelled by the first plane towards north will be equal to speed of the first plane multiplied by the time. the speed is given as 1000 kilometers per hour and the time is 1.5, and 1.5 can be written as 3 by 2. So the distance OA will be equal to 1000 multiplied by 3 by 2, which gives you the answer as 1500 kilometers. So the plane 1 in 1.5 hours have travelled 1500 kilometers. And now calculate the distance which is covered by the second plane, which will be equal to the speed of the second plane multiplied by same 1.5 hours. So you will get the speed of the plane is given to you as 1200 kilometers per hour and the time is again 1.5 hours. Multiply and get the answer, you will get it as 1800 kilometers, right? So OB is equal to 1800 kilometers. You can see that it is forming a right angle triangle. So in any of the right angle triangle, you can apply the Pythagoras theorem. Applying in triangle AOB, you will get OB square plus OA square is equal to AB square, right? Okay, put the values 1500 square plus 1800 square is equal to AB square, and AB is the distance between the two planes. So when you calculate, you get the answer AB as 300 root 61 kilometers.
Question number 11. A guy wire is attached to the vertical pole of 18 meters height and is 24 meters long. It has a stake which is attached to other end. How far from the base of the pole should the stake be driven so that the wire will be taut? Taut means tight, right? So we have got this AB as the vertical pole. There is a guy wire, which is a wire actually. The length is BC and its length is given as 24 meters. We are supposed to find out where should the stake be from the base of the pole, right? Now you can see a right angle triangle, so we can very well apply the Pythagoras theorem. Now according to the Pythagoras theorem, we know that the side BC square is equal to the side AC square plus AB square, right? Now what is AC? X square plus AB square, which is 18 square, and that is equal to 24 square, right? Now calculating for X square, take 18 square to the other side of the equation, you get 24 square minus 18 square. 24 square is 576, 18 square is 324. Subtract the value, get us 252. So what is X? X is equal to under root of 252, which is 6 root 7 meters. So what is the distance of the stake from the base of the pole? It is 6 root 7 meters, right? Okay.
In question number 12, two poles of height 6 meters and 11 meters stand on the ground and the distance between the foot of the pole is 12 meters. Find the distance between their tops. You're given two towers, that is AB and BC as 11 meters and 6 meters respectively, and the distance between them is given as 12 meters, which is AB. Let the distance between the poles top be DC, and that is equal to X meters, right? Okay, now we have got AD is equal to BE, right? So each should be equal as they are the opposite sides of rectangle. Now we have this AC is equal to BC minus BE. So 11 minus 6, which gives us the value as 5 meters, right? Okay, now you can see that this value AB and ED are again equal, so they are also opposite sides of a rectangle, so each is equal to 12 meters, right? You can see that triangle DEC is a right angle triangle, so we can apply Pythagoras theorem to it. So we have got DC square is equal to DE cos square plus EC square, right? Okay. So put the values. X square is equal to 12 square plus 5 square, which is equal to 144 plus 25, which is equal to root of 169, and that is giving me the value of X is equal to 13 meters. So the distance between the tops of two towers is 13 meters. This is your answer. In question number 13, D and E are points on CA and CB of triangle ABC, which is right angled at C. You are supposed to prove that AE square plus BD square is equal to AB square plus DE square. D and E are the points on AC and CB respectively, right? You're already given that this is a right angle. Now what you have to do is join the point E and D and also join B and D, right? You get now 3 right angle triangles, right? What are the 3 right angle triangles which you get? The 3 right angle triangles you get is triangle ACE. You can apply Pythagoras theorem to any of the right angle triangles. So you have got AE square, hypotenuse ka square, is equal to AC square, that is base square plus perpendicular square. Mark this as equation number 1. The next triangle which you have to consider is triangle BDC, because you want BD. So what is the value of BD square? You know that is equal to CD square plus BC square in triangle BDC, because D is, we know that C is again a right angle in the triangle BC and D. Now you consider triangle ECD, which is a tiny triangle here, and apply Pythagoras to the triangle. You will get DE square is equal to CD square plus EC square. Mark this as equation number 3. And you also have a large triangle, that is triangle A, B and C. We can apply Pythagoras theorem here too, because AB is your hypotenuse, AC and BC are the perpendicular sides. So apply Pythagoras theorem and mark this as equation number 4. Now you add up equation number 1 and 2. What do you get? You get A square plus BD square is equal to AC square plus CE square plus CD square plus BC square. Slightly make some rearrangement. You bring this AC and BC together because you have got AC square plus BC square is equal to AB square, and CD and CE is brought together. We have shown it in a bracket so that you can identify them. And from equation number 3 and 4, you instead of AC square plus BC square, you can write it as AB square, and instead of CD square plus CE square, you can write BD square, right? Substitute the values here. You know now AE square plus BD square is equal to AB square plus DE square, and this is what we are supposed to prove. In question number 14, perpendicular from A on side BC of triangle ABC intersects BC at D such that DB is equal to 3 times of CD. Prove that twice of AB square is equal to 2 times of AC square plus BC square. Right? Okay, you are given from point A, you are going to draw a perpendicular to side BC of triangle ABC, and you are also given that this DB is equal to 3 times of CD. Here you can see 2 right angle triangles, and you can apply Pythagoras theorem to each of the right angle triangles. But consider whatever it is given to you. We are given that this DB is equal to 3 times of CD, right? And we also know that the side BC is equal to DB plus CD. So instead of DB, you write 3 times of CD, and then again you have got CD. So what is BC now? BC is equal to 4 times of CD. Or you can write CD is equal to 1 by 4th of BC. And now substituting the values of CD, you can also calculate that DB is equal to 3 by 4th of BC, right? Okay. Now you consider triangle A, D and B, which is the right angle triangle. So you can apply Pythagoras theorem. You get AB square is equal to AD square plus DB ka square, right? And now we also have another triangle, triangle A, C and D. This is also a right angle triangle. So again we can apply Pythagoras theorem. So we will have AC square is equal to AD square plus CD square, right? Okay. Now if you have to subtract equation 5 from equation number 4, what do you get? AB square minus AC square is equal to DB square minus CD square, because AD square and AD square cancels off, right? Okay, now instead of DB square, we can write 3 by 4th of BC ka square, and instead of CD, you can write 1 by 4th of BC square. So on calculations, 3 by 4 square will give you 9 by 16 BC square, and 1 by 4 square will give you 1 by 16 and that is BC square. You can subtract these two, which will give you 8 by 16 BC square. 8 by 16 will give you 1 by 2 of BC square, right? Okay, now cross multiply or multiply 2 to both sides. You will get 2 times of AB square minus 2 times of AC square is equal to BC square. Then again take minus 2AC square to the other side. You will get 2AB square is equal to 2AC square plus BC square. And this is what we are supposed to prove. In question number 15, you have got an equilateral triangle ABC in which D is a point on side BC such that BD is equal to 1 by 3rd of BC. You are supposed to prove that 9 times of AD square is equal to 7 times of AB square. ABC is a equilateral triangle. So what is BD? It is equal to 1 by 3rd of BC. It is given to us. So let us prove 9 AD square is equal to 7 AB square. For that, do a construction, draw a line AE such that this line AE is perpendicular to the side BC. And since we draw a line perpendicular from one of the vertex to other side of an equilateral triangle, it will bisect the side on which it falls. That means the side BE and EC will be equal to each other. So you can write in an equilateral triangle AB is equal to BC is equal to CA and mark this as A. Okay. Now what is BD? It is given as 1 by 3rd of BC. So it is 1 by 3rd of A. BE is equal to EC and that is equal to half of A. Therefore, what is DE? DE is equal to BE minus BD, which is equal to half of A minus 1 by 3 of A, which comes out to be 1/6 of A. Now you consider the triangle ADE, which is a right angle triangle. Apply Pythagoras theorem to it. You will get AD square is equal to AE square plus DE square. Now consider the triangle AB and E, which is again a right angle triangle. Then you will have AB square, which is the hypotenuse square, is equal to base square plus perpendicular square, BE square plus AE square. So now AD square is equal to, instead of AE square, you can write it as AB square minus BE square. Bring B to the other side. You will get AB square minus BE square plus DE square. What is AB square? It is equal to A square. What about BE? It is equal to half of A ka square. And what about DE? It is 1 by 6th of A square. So on solving, you will get A square minus 1 by 4 of A square plus 1 by 36 of A square. If you simplify, you will get it as 36 A square minus 9 A square plus A square by 36. If you take the LCM, which comes out as 28 A square by 36, you can cancel and get simplified it as 7 by 9. So you have got AD square is equal to 7 of AB square divided by 9, because instead of A square we can write it as AB square, right? So we have got AD square is equal to 7 AB square by 9. On simplification you will get 9 AD square is equal to 7 AB square. And this is what we are supposed to prove. In question number 16, in an equilateral triangle, prove that 3 times the square of one side is equal to 4 times the square of its altitudes. You are given triangle ABC is an equilateral triangle. We are supposed to prove that 3 times of AB square is equal to 4 times of AD square. Now, from point A, draw AD perpendicular to BC and we will get BC is equal to CD, because the perpendicular drawn from any side of an equilateral triangle bisect the side on which it falls. So let us use Pythagoras theorem. We already have the side AB is equal to side BC is equal to CA, which is the sides of the equilateral triangle, and sides of equilateral triangles are equal, we know. And we also got BD is equal to CD by construction. And BD is equal to CD, which is equal to half of BC, right? Now, in triangle AD and B, it is a right angle triangle. So, we can apply the Pythagoras theorem and get AB square is equal to AD square plus BD square. AB square is equal to AD square plus half of BC square. Because instead of BD square, we can write it as BC square, right? Half of BC. BD is equal to half of BC. Substitute the value. You will get AB square is equal to AD square plus 1 by 4th of BC square, right? Okay. So, calculate the values and you get 4 AD square plus BC square by 4 is equal to AB square. Cross multiply, you will get 4 AB square is equal to 4 AD square plus BC square. So, 4 times of AB square minus BC square is equal to 4 times of AD square, but BC square is also equal to AB square. So, 4 AB square minus AB square is equal to 4 times of AD square, right? So, you got the relation 3 times of AB square is equal to 4 times of AD square, and this is what we are supposed to prove.